Here we're going to take a look at the binary, decimal, and hexadecimal conversion. Binary is a base 2 counting system, decimal is a base 10, hexadecimal is a base 16 counting system. Computers use a base 2 counting system since at their simplest level they can handle an on or an off state, which gives us two states. You and I use a base 10 counting system every day. And hexadecimal is used to simplify our view of the binary system that computers use. Now, in terms of the computer, a bit is a single 0 or 1. A nibble is a series of 4 bits. A byte is a series of 8 bits. And a word, depending on your CPU, is a series of 32 or 64 bits. When looking at a byte, it's made up of 8 possible positions. To begin converting a binary byte to a decimal number, we'll number the positions beginning from the right with 1 and doubling in each space as we move left. So we put the 1 in, we double it. 2, we double it again. 4, we double it again. 8, then 16, 32, 64, and 128. For each position where we have a 1 above these numbers, we add that number to the total. We ignore all positions where the number above is 0. We add all the numbers up, and this gives us the decimal version of this binary byte. So, let's convert 1011, 1001, starting with 128. That's the first one on the left that has a 1 above it. We'll add in 32. That's the next one to the right that has a 1, giving us 160. We add 16, the next one over, giving us 176. We add an 8, which is the next one over, which gives us 184. We add 1, giving us 185, which equals binary 1011. 1001. Looking at the maximum value, we put 1s in all the positions. We'll find that there's a total of 255 possible values at a max. So here 128 plus 64, 192 plus 32, 224 plus 16, 240 plus 8, 248 plus 4, 252 plus 2 is 254 plus 1 is 255. Now, knowing that this byte can start at 0, we range from 0 to 255, which gives us 256 possible values. So, extending what we just learned, a bit contains 1 bit, or a 0 or a 1, so it's possible 2 values. A nibble gives us 16 possible values with 4 bits. A byte gives us 256 possible values with 8 bits. A word, 32-bit word, gives us about 4 billion possibilities. 64 bits, gives us a very large number, and you can read that number. So, going back to how we convert a byte to a decimal number, remembering that these 8 bits represent 2 nibbles, each of which provides 16 states. I'm going to number these 1, 2, 4, 8, and then again 1, 2, 4, and 8, as opposed to the way we did it previously, doubling at 8 to 16 to 32 to 64 and 128. At the same time, remember that the hexadecimal numbering system ranges from 0 to 9, and then A, B, C, D, E, and F representing 10, 11, 12, 13, 14, and 15. So A through F represent numbers in hexadecimal. So looking at hexadecimal A 0 through F, we can see the binary counterparts, 0, 0, 0, 0, 0, 0, 0, 1, so on and so forth, and then the decimal representations that go from 0 to 15. Binary notation is the format that the computer can understand, while we can and do work with decimal numbers easily. A good middle ground is that hexadecimal notation that we can understand with a little bit of effort and can be translated into notation that the computer can understand relatively easily. Another consideration we also need to take into account is the amount of space used to store information. By using hexadecimal, we can store more information in less space. Looking at the values 10 through 15, in decimal we would have to store 2 digits, while in hexadecimal notation we only need to store 1 digit. So breaking down the basic categories of numeric values in the computer industry, 1 is a binary digit. Each of those makes a byte. There are 1,024 bytes in a kilobyte, 1,024 kilobytes in a megabyte, 1,024 megabytes in a gigabyte, and 1,024 gigabytes in a terabyte. Now, the number 1024 basically takes 128 that we saw earlier by doubling 1 7 times. Double it again here, it becomes 256. Doubling 256, it becomes 512. Doubling 512, that's the 1,024 that we saw through this portion of the exercise.